Okay, hello, pre-cal guys. So we are second part to 2-3. So we're still dealing with the graphs of polynomial functions. But today you can see our 2 points. One is, how do we find the x-intercepts? I mean, you can find y-intercepts pretty easily. So I didn't stress that, but you should be able to find that. So how do we find x-intercepts algebraically? Algebraically means what? Other than doing algebra. Doing algebra means what? Yes, by hand, working it out, okay? So we're going to work it out, paper and pencil. And then you'll see that determining the multiplicity of roots or zeros, so a synonym for root is zero, to aid in curve sketching. So how do we know, how does that help us with curve sketching? I'll show you. We're going to graph each one of these, okay? All right, so here's where we're at. If I go to this first problem here, right now, what do we know about the graph? We should know 2 things. You should be able to look easily and tell me 2 or 3 things about the graph. So we'll go to example 1, part A. What do you know about the graph on part A? Yes?
It's odd and it's negative.
So what does that then tell you about the graph?
That the end behavior is one's going to be going up, one's going to be going down.
Which one goes up, which one goes down? You can use left and right. So
yeah,
as we go,
the left side's going up, the right side's going down.
So left is synonymous with x goes to negative infinity. As x goes to negative infinity, or as we go left, the graph goes up, and as we go right, the graph goes down. So that's very good. So just like that graph, right? So it has the same, that's how I look at it. I just cover up everything, look at the first term. So we know that. We don't know what's happening in here, although we should have an idea. It cannot have any more than how many hills and valleys? 2. Okay, so we know at maximum it can have is 2 hills and valleys. Okay. All right, and you should be able to see the y-intercept. What's the y-intercept? Not dying. I hope not.
0.
0. Very good. How'd you get that? Or plug in a 0 for x. There is a y-intercept at 0. Plug in a 0 for x, your answer is 0. The constant at the end, when it's expanded like this, is your y-intercept. Because think, y-intercept comes from plugging a 0 in for x. So when I plug a 0 in for x, what do I get? 0. So 0, 0 is the y-intercept. So those 3 things you should know. So what we're going to do today is we're going to find the x-intercepts so that we can it's just basically connecting the dots. It's completing this graph by hand by connecting the dots. Okay, so how do we do that? Well, so on part A, if I want to solve, so we're going to solve for x because we're going to take the function and set it equal to 0. Now, the main tool that you're going to use on all these, it's a review of factoring. How do I factor? Okay. So when I look, the first thing I look for is what's in common. So I always want to try to factor that way if I can. Then I got to remember how to factor quadratics. Then I also want to remember factoring difference of 2 squares. And I also want to remember factor by grouping. So I'm going to just list these to the side. So what's factoring? Just what's in common. So we want to be able to do that. We want to be able to do how do you factor just an expanded quadratic? How do you do difference of 2 squares, which we've done these, so I'm just reviewing you on it. And then how do you factor by grouping? Factor by grouping. I'm not saying you're going to do all these on this one function, but we will do them all on these 4. Okay? So what's in common? What do both terms have in common? X. In this case, I would prefer to factor out a negative x, so that if I factor out a negative x, it will then turn this not into a negative, but a positive what? Squared. And if I take a negative x from here, instead of a plus 9, it's going to be, it will be minus 9. Okay, there's that. Okay, so that's my first step on that problem. You see if you can complete it and find the solutions. How many solutions are guaranteed by the fundamental theorem of algebra? 3 complex solutions. Third degree polynomial has 3 complex solutions. Fundamental theorem of algebra. So don't forget FTA. Nth degree poly has n complex solutions. Complex means real or imaginary. So there should be 3 real or imaginary solutions. Doesn't mean there's 3 X-intercepts, but it means there's 3 real or imaginary. Okay, so how do you factor this, or does it factor? Difference of 2 squares, that's exactly right, it factors x minus 3, x plus 3. Now, use the multiplication rule when you have an equation equal to 0, you know, either the first piece equals 0, or the second piece equals 0, or the third piece can equal to 0, so I set each one equal to 0. And I'm going to solve for x. Now when I get my answers, I get x is 0, x is 3, and x is negative 3. I know I call all of those single roots. So here's my thing. Go back one step. All right, Spencer, when you look at the left-hand side, if I was just to graph negative x, what does that graph look like? Like, what's the shape? Just if I had said graph okay, linear, x minus 3, do the same thing, linear, x plus 3, linear. So as I go back a step, as I get my solutions, notice that each of these are linear functions. That tells me that my graph is going to be like a line through that intercept. So the multiplicity of all these is 1, because you got each answer one time. You didn't get a double answer. You didn't get 0 twice. You didn't get 3 twice. I call them all single roots. And at a single root, the graph just crosses the x-axis just like a line would. It goes straight through the x-axis. I mean, it's not linear because these are all curves, but I'm saying it goes through the x-axis, okay? So now, the algebra part, we've done. We found all 3 of our x-intercepts. So now let me take this box because we know that's not part of anything. But now I know some important things. 0, negative 3, and positive 3. Those 3 points have to exist. Okay? Now here's why I put it all together. A polynomial is everywhere continuous. We should try to fill in the blanks here, right? Right? There's no gaps, breaks. So I know that from here to here it has to connect. I know now that if that's an x-intercept, it has to go through there. Now I can't just cut across here like that because there's another point. So it's kind of like connect the dots. So now I'm going to just kind of say, well, now I know I've got to turn around at some point and go through that point, because that's another point. But as I turn, can it be a sharp turn, or does it need to be a smooth turn? Smooth turns, so I turn, I go through there. Now I know I got to finish here, and I know I got to go through that point, so I turn again. Now where I turn, how high, we're not going to find those. That's calculus. Okay, so I turn again wherever I kind of feel, and then I finish. And now I put the graph together. Because at a single root, the graph just crosses the x-axis at a single root. And I've connected the dots. Third degree polynomial has 2 hills and valleys, which is fine. And there you go. Any questions? So really, there's several parts to this problem. One is factoring. When we do these, we're gonna need to factor. The second is remembering our characteristics of polynomials. And then the third thing is, every time we get a different root, I'll tell you what it does there. So as we work these, we will, what was I trying to say? I'll add in the rule for each root. So a double root, what happens? A triple root, what happens? A quadruple root, which you very rarely get, what happens? What does the graph do? Because it does different things. Now, how can you verify this? So let's say Austin's like, well, what could you do? How could you double check to see if this is right? Yeah, just graph it on your calculator. You see what I'm saying? Just graph it on your calculator. Your calculator will graph all these. But your ability to be able to solve these equations is important by hand. Okay, my job is to prepare you for calculus. So in calculus, that's something that we do there. We don't rely on the calculator to solve those equations. Okay, there's part A, done. All right. Okay, oops. Well, we know all those different types. Part B. So I'm right now we're keeping it simple with third degree, fourth degree polynomial. So part B, what do we know right now before we even get started? What's the end behavior?
No.
X cubed. So again, I just cover this up and I say, what would that graph do? Left it goes, right it goes, there's that. All right, now I'm going to find the x-intercepts. All right, so now I'm going to look for the x-intercepts. I know what the y-intercept is. I'm going to do the y-intercept real quick. What's the y-intercept? 0 what? -8. Okay, again, if it's in this expanded form, you plug in a 0, you're only going to be left with a -8. It's your y-intercept. Okay. All right, now, how do you factor this? Because here's the problem. Yeah, you got an x cubed and x squared and x, but there's no x here. There's no 2 here. So I can't factor a 2 out and I can't factor an x out. Grouping. What tells you it's grouping? 4 terms. You have 4 terms. 1, 2, 3, 4. Always try factor by grouping. So I group the first 2 together. I group the last 2 together. You see if you can finish the problem now. Now, as you finish and you solve, Andrew, how many complex solutions are guaranteed? 3. Now, again, you may only get 1 real and 2 imaginary. You may not see them, okay? But you should get 3, so there should be 3 answers, okay? So you may get 2 imaginary solutions that those graphs, that wouldn't appear when I graph. do it with 2x minus 4. So what comes out of the first group? What factors out? X squared. You're left with x minus 4. What factors out of the second group?
2.
Left with x minus 4, which is good. Now, each group has an x minus 4 in common. I factor that out. And if I take out an x minus 4, I'm left with what on the first? I'm left with what on the second? 2. All right. Now you cannot do anything else with this in the parentheses. There's no more factoring you can do. So you stop. It's okay. The fact that I have multiplication, now I can stop and solve. Anytime I have a linear factor and a quadratic factor, I can get the solutions. Okay? So I take my linear factor, set it equal to 0. I take my quadratic factor, set it equal to 0. Here I get x is 4. Right? Here I get x squared. How do you solve? I just move the 2 over and take square root, right? So x squared is negative 2. Do my square root. X is plus or minus the square root of negative 2. Always when I solve, I should put plus or minus. And we know with square root of a negative, the negative moves in front of the square root as an from 2.1 complex numbers. I. It all joins together, guys. So there's that, there's that. 1 real, how many imaginary? 2. How many complex solutions? 3, which we're guaranteed. But now when I go to graph, I only graph the real, you can't do an imaginary x-intercept. So the only x-intercept I have is 4. 1, 2, 3, 4. So now here's where it gets tricky. I don't know if it has like a heel or something below. Now I do know it crosses at -8, right? So I do know that. So what I'm saying is I don't know if it just squiggles through here. I don't know if it like has a hill and a valley below that. I don't know. See, you'll get that wrong. So the best I can do is this. Now what you can do is you can type in on your calculator and see. Like it may hill and valley underneath because it doesn't cross. Okay. All right, you see what I'm saying? Or it could do like this. You know, it could just kind of go here and do like that. I don't know, because I don't know what those are, those hills and valleys. So I'm going to guess, and I'm just going to do this. You can plug in and tell us. Does anybody have the graph? Isis, do you have it over there? I would have my calculator out on every one of these. Every one of these, I'm doing it by hand, I'm plugging it in on the calculator, I'm verifying. Anything?
In the valley, negative, or y negative 12 plus 4 x.
Oh, way down there?
Yeah.
So it came, it went like that, and it goes through.
Yeah.
We won't know that, okay? So I'm just gonna do that. But that I do know. Then it has to cross at 4. That we got right. So you're saying it goes like this, and then like that, and it goes through?
Yeah.
Yeah. So, all right, there we go. Okay? All right, on to the next one. So, as you look at the next problem, I think the ones that, I'm making these up off the top of my head. So it may not go as smooth. I'm just getting stuff that we can factor. I don't know about their graphs. So the ones that you'll get in a homework, the graphs should be a little bit more, I don't think they'll fake you out on any of those. All right, as we look at part C, how are you gonna approach this one? Because now it's an x to the 4th. Now what should the end behavior be on part C? Both up, all right, so that we know. Positive and even degree, both up. Now we need to find the intercepts. What's the y-intercept? 0, because there's no constant at the end and this is expanded. All right, if I plug in a 0, I get a 0, so we got that. Right now we at least have that. But there could be a lot more going on, so we need to solve. So now we're going to take that and set equal to 0. What should always be your first way to factor? Like when you're factoring, what should be the first thing you look for? something to have in common. And there you go. We all have what in common? There you go. And you can factor it. Then you'll get a quadratic. That quadratic will factor. Okay, so once I take out an x squared, I'm left with the quadratic x squared plus 5x plus 6. What are the two questions I ask myself when I try to factor a quadratic? What two numbers multiply to give the last number and add to give the middle number? That's what you should ask. When the coefficient of is 1. What two numbers multiply to give 6, add to give 5? Those are 3 and 2. Now it's completely factored. Oh, it's technically not because I could factor x squared, but I look and I know I can solve each of these, okay? By the fundamental theorem of algebra, I should get how many solutions, Colton? Yeah, not at least. 4. Exactly 4, real or imaginary. So when I go to set each one equal to 0 and solve, let's see what happens. So let's go in reverse order. X plus 2 is 0, move the 2 over, I get x is negative 2. X plus 3 is 0, x is negative 3. X squared is 0, what number squared is going to give you 0? 0. So if I write those 3 down, I only see 3 answers. But technically there's 4. So can somebody explain to me where's the 4th answer?
Well, you got 2 zeros like on the last one.
We have 2 x's.
Yeah, this is actually plus or minus. If you look at it two ways. One way is you could have just factored x squared and made it x times x equals 0. So there's technically 2 x's there. And then if you set each of those equal to 0, you would have got the same answer twice. That's where it's misleading. Or the other way you could have looked at it is when you solve x squared is 0, when you do square root, you should put plus or minus. So plus square root is 0, minus square root is 0. Either way, there's 2 solutions. Okay, so this is called a double root, or the multiplicity is what? 2. And if the multiplicity is 2, or you have a double root, what happens? The graph bounces at the intercept. So it doesn't cross. So it either bounces like this or bounces like this. It just depends on the behavior of the graph. Okay? And so then, so let's see. So I'll go through. So what do we have? Negative 3. One, 2, negative 2. Oops. Negative 3. So let's see. Those are single roots. I'll cross, turn, cross, turn, and I'm gonna do what here? Bounce. Because if I don't, if I just cross it, the end behavior won't match. See? So I can't just go across, I gotta bounce one more time to be able, it's kind of weird looking W shape. Now where do I put these two? I just use the force. I'll feel it, okay? Just try to make the graph go as good as you can there. All right, 2 more problems and then we'll do part D, then I'll add a part E on and we'll be done. Okay? All right. You see if you can do part E on your own. Part D, sorry. Okay. Is there anything in common you can factor out? Yeah, that's what I would factor out. I don't like having a negative at the start of my quadratic. So I'd always pull a negative out when I can. All right, we know our end behavior on part D, up, left, down, right. I'll take the negative x out, you're left with x squared minus 6x plus 9. Anybody know what that is called? It's got a special name. It's a perfect square trinomial. Because this ends up having the same two factors. Because what are the 2 questions you asked? What 2 numbers? Multiply to give 9, add to give negative 6. What would they be? Yeah, so minus 3 minus 3. And now it's completely factored. Now you set each factor equal to 0. Those are all what kind of roots? Any double roots, single roots? What kind of roots are they? They're all single? Yeah, this is the same answer twice. So what do you call that? You're gonna get 3 twice, so it's a double root. That's a single. So you get x is 0 here. Here you get x is 3, x is 3. So that's a double root. So now we know there's a bounce there. Okay? So 0, 3. What are we going to do at 0? Go through, turn, bounce, and there you go. Okay? So what we have not discussed is if there's a triple root, which it can happen, and it's a little bit different at a triple root. I call it a squiggle. It squiggles through. So what you may get is you may get something like this, where it's already factored, so I'll show you. Okay, so we'll do one more problem. Can I erase these problems over here? I'm sure at this point you've written them all down. So part E is a polynomial that's already factored for you. So let's say we had y equals negative x cubed, x plus 2, x minus 4. So does everybody see that that polynomial is factored? Now the first question is this. If I want end behavior, let's be careful. It's not a third degree polynomial. So what I do is this. I take the first piece in each factor and multiply them all to see what's my degree. So it's not a third degree polynomial, it's a what degree? Fifth, very good. Everybody see how we got fifth? Because if you were to expand this, which we don't want to do, it would be negative x to the fifth plus dot, dot, dot. So I don't care about the rest because I just care about that biggest term. Can everybody foresee that if we were to expand this, when I multiply, that these two x's would multiply to give an x squared, and x cubed comes x squared, you add your exponents. So there you go. So our end behavior now is the same as what we just had. It's going to be up, left, down, right, but it's a fifth degree, which means at most, how many hills and valleys could it have? Could have 4, doesn't have to have 4. How many solutions are guaranteed? Complex. 5 solutions, but that doesn't mean you'll get 5 different answers. We'll see what happens. The good news about this problem is, now, one thing you can't say the y-intercept is 0. That's wrong. Well, maybe not. It is 0 on this one. Sorry, because it is. But you got to think when it's expanded, so be careful. Just because it's factored like this, like had that been another, like an x plus 1, it wouldn't have been 0. But since that's an x cubed, when I plug in 0, it all goes to 0. So you have zeros of the y-intercept. All right. So the good news is it's already factored. Set it equal to 0. Now find your solutions. And you should see you get a triple root. So if we have a multiplicity of 3, which I call a triple root, the graph squiggles. So it squiggles like an x cubed. One or the other, like an x cubed graph. Okay? Notice how the degree, what does an x cubed graph look like? It's going to have that squiggle to it. So it should take you 2 seconds. Set each factor equal to 0 and solve. And that should finish the lesson once we finish this. Okay, so what are our solutions? Haley, what did you get? X is what?
I got 3 zeros and then got negative 2 and 4.
Yeah, so technically she's saying, look, we could make this x times x times x. So you're going to get x is 0 3 times. I usually just put TR under it, just to tell myself. Here you get x is negative 2, and here you get x is 4. And so then we'll plot all of those. Negative 2, 0, and 4. All right, let's see what happens. So I do what at negative 2? Straight through. Turn somewhere, I use the force. Now when I go to 0, I do what? Like an x cubed graph. So it still goes through. The only time you bounce is when it's a double root, or if you had a quadruple root. Then I turn, and I go straight through 4. And you could type this in on your calculator and verify. There you go. That's the lesson. Good? All right, 2, 3.